Okay, good morning. So today we're going to talk about chemical bonding, but first we're going to actually review the bell ringer. What we have up here is two elements, and you're having to identify each. Remember, you count the number of rings that you see on each element. For instance, number one. The inner one is actually the nucleus, so you do not count it. So outside of that would be one right here, two. So I see it has two rings, so therefore it's in the second period. Now to find out which element in that second row, you count the number of dots in the outer shell. One, two, right here. So you go over two elements over, and then that one would actually be beryllium for number one. They want to know the name of the element, beryllium, number two, valence electrons, the electrons in the outer shell, and what period you count your rings. So for instance, number two down here, remember this is the nucleus down here, so you count one and two. Again, it's in the second period. Your valence electrons are dots in the outer ring, 1, 2, 3, 4, 5, 6, and 7. So therefore it has 7 valence electrons. You go to the 7A column, go up, and you find out that this element is actually fluorine. Okay? Now, let's do some other review at this time. Metals, remember metals, they are the largest group. They're found on the left side of the periodic table. Actually, they're to the left of the stair-step line. And nonmetals are to the right of the stair-step line. They do include hydrogen, which is all by itself on the left side. Valence electrons, remember, are those electrons that are found in the last energy level or shell. And the code for that would be 1, 2, 3, 4, 5, 6, 7, and 8. When you look at it, it is the actual number associated with the Roman numeral associated with the letter A. And to recap, our ions are actually called a charged particle. Now here's something new. A positive charge ion has a term called cations. Okay, they actually have a positive oxidation number. We'll go over the oxidation numbers in just a second. And anions are your negative charged or negative oxidation numbers. So your ions are the charge. All right, oxidation numbers, they're the number of electrons an element will either gain or lose in order to be stable. The magic code is 8. In order for an element to be stable, needs to have at least 8 valence electrons or 8 electrons in the last shell. Or if they get rid of all of them, the inner shells are full, so therefore it would be stable. For instance, the alkali metals plus hydrogen have a positive 1 charge. The alkaline earth metals right here have a positive 2. Jump over to the A columns. Boron family right here has a positive 3. The carbon family right here has plus or negative 4. That means this family right here can either gain 4 or lose 4. They could go either way. Then this column right here, which is the nitrogen family, they have a negative 3 charge. This one is the oxygen family. They have a negative 2 charge. And then the halogens have a negative 1 charge. Now the noble gases, they have 0 charge. They're already full, so therefore they don't need to gain or lose. They are stable. All right, so we're going to start first of all with chemical bonding. And with chemical bonding, basically it is a force. A bond is a force that holds 2 or more ions or atoms together. And there are 3 types of bonds we're going to talk about today. The first one's ionic. Then you have covalent, and then you have metallic. So we're going to take each one step by step. The first one's ionic, and ionic, you're basically one gives up, one gains electrons. Those electrons in the outer shell. For instance, sodium has 1 valence electron in the outer shell, it's right here, and chlorine has 7. So sodium could give up the 1, You see this one right here. Give up the 1, and chlorine can gain the 1, and therefore they're happy. They're both stable because the inner shells of sodium are actually full, and by chlorine gaining that 1 gives them 8, which is what they need. It's also an ionic, is between a metal, one thing on the left, and a nonmetal, one thing on the right. Covalent bonds are where they share. They're actually kind of fickle in that they can't afford to give up all their electrons because they might only have 1 electron. A great example of that one is hydrogen. Hydrogen, when it combines with oxygen, actually they only have 1 valence electron in the outer shell, and therefore they can't afford to lose it. Usually covalent bonds are between 2 nonmetals. An example right here is carbon dioxide, CO2. Or this one right here, hydrogen bonding with itself. Because it's in the first row, the maximum amount of electrons in the first shell is 2. So 2 hydrogens bonding together means that they're full and stable. Okay? Metallic bonds, again, they're sharing electrons. The main thing to note about a metallic bond, it's a bond between 2 metals, a metal and another metal. A lot of your pots and pans, which are an alloy, is an example of metallic bonds. Okay? All right, so now you have to tell me whether or not you think these are either ionic or covalent. Key thing to remember, if it starts with a metal, okay, if it starts with a metal, odds are it will be ionic. But if it starts with a nonmetal, it is covalent. Remember, ionic is a metal and nonmetal, and covalent is a nonmetal and nonmetal. So all you need to do is just look at the very first element. And if it is a nonmetal, it's covalent, and if it starts with a metal, it's probably going to be ionic. So try these at your seat. Okay, let me go back and hold on this one for you. So try these 6, and you tell me whether or not they're ionic or covalent. All right, number 1, K, potassium, is a metal. And fluorine's a nonmetal. Metal, nonmetal, it's ionic. Number 2, phosphorus is a nonmetal. Bingo. If it starts with a nonmetal, it's probably going to be covalent. And both of these are 2 nonmetals. Phosphorus and oxygen are 2 nonmetals. So therefore, number 2 is covalent. Number 3, C, carbon. Now, carbon's one of those ones that could go with a charge plus or negative 4. Okay, but carbon is on the left side, on the right side of the stair-step line. Carbon is a nonmetal. So carbon and oxygen, that's carbon monoxide, that's a covalent bond. All right, magnesium and oxygen, okay, combined together, metal, nonmetal, so it's ionic. Hydrogen and oxygen, both of these are 2 nonmetals, therefore it's covalent. And number 6, lithium's a metal, chlorine is a nonmetal, it's ionic. Now there are some special atoms out there that like to combine with themselves. And they're called the super 7. There are only 7 of them found on the periodic table. And they're all covalent bonds. Hydrogen's 1, and then you have fluorine, chlorine, bromide, iodine. Of course, we said hydrogen, oxygen, and nitrogen. So when we write these free in nature, they're always combining with themselves. So you have a subscript of 2 there. So these are called diatomic molecules. Okay? All right, so here's your exit ticket for today. You tell me whether or not you think either of these are ionic or covalent. And I'll leave this up for just a second. And we'll go over these in class. Okay? Thank you. I hope you enjoyed today's lesson. Bye.